Hey Opties! Today we're talking about vertex form of a quadratic. So this is one of the forms that you can write the equation of a quadratic in. And we call it vertex form because it easily shows what the vertex of the parabola is. So a vertex is either the low point or the high point of your parabola. It's really the turning point, and it's the point at the top of the hill or at the bottom of the valley, if you want to think about it that way. So we have our vertex form written here. Y equals A times the quantity of x minus h squared plus k. And h and k are a different color because those are the x value and y value to make our vertex. And a is just a factor, meaning just some number that's being multiplied by the quantity of x minus h squared. And a will tell us some transformations just like h and k will. So if a is less than 0, then that's an x-axis reflection because that means a is negative. If a is between 0 and 1, then that's a vertical shrink / compression by a. And if a is greater than 1, that's a vertical stretch by a. The transformations that h will tell us is it will tell us the left or right where to go there, and then the k will tell us up and down. Looking at our two graphs here, we see that HK is the vertex for either of these, whether it's a positive parabola like this one, or if it's a negative parabola like this one. So if it's positive, that means your A is positive. So the whole thing's positive, there's a plus out front. That means that you're going to be pointing upwards. Your end behavior is up, up. And your HK is still this vertex right here, which is your turning point. And it's the lowest point on the function. If, however, you're negative, so it means A is negative, you've had an x-axis reflection from your parent function. Now your end behavior is down, down, and this is your vertex, and that's the highest point on your function. That's the top. That's like the toppest point of your hill. So here's a point to ponder. Notice that in our equation, it's a minus h. So our point just has a regular old h. So if we substitute our h into the equation, then it's going to change sign. Because if you subtract a positive, it becomes negative. If you subtract a negative, it becomes positive. So here's an example. If your vertex is 2, 3, then the equation 2 will be negative, such as maybe y equals the quantity of x minus 2 squared plus 3. So just be aware of the sign change there. And again, that's because you're subtracting h in the equation. Let's look at some properties of quadratics that come about from knowing our vertex. So the axis of symmetry. So if you think about any parabola, it is symmetrical about this middle line, and that middle line always occurs at the x coordinate of the vertex. So you could fold the parabola on that line and it would land right on top of itself. So either way you fold it, it's going to be perfectly symmetrical. That's why it's called the axis of symmetry. And an axis in general is just a line. So anytime you want to find the axis of symmetry, all you need to know is the x coordinate of the vertex. So here's our vertex. This will be HK. And notice it's x equals h. So that's the equation of this line. Let's take a look at extrema. Extrema is an overall term to talk about maximum or a minimum. So we know that a maximum or minimum is a high point for maximum or a low point for a minimum. So that's going to be some sort of y value because it's talking about a vertical number. A height or a low point is vertical. So we're going to have y equals k, which is the y coordinate of our vertex, to be the equation of the maximum or minimum always. Now, you just need to know, is it a maximum or is it a minimum? If you're given a graph, it's really easy to tell because you can tell by looking. Does it have a high point, which would be a maximum, or does it have a minimum, which would be that low point? But if you're looking at an equation, if it's a negative out front, so your a is negative, that's going to have a maximum because remember, that means you have an x-axis reflection. So you've gone from this way, up, up in behavior, to this way, down, down in behavior. So looking at your minimum, it's going to be a positive a value that lets you have a minimum. So a quick way to remember this is to say the y value of the hill for maximum or the y value of the valley for minimum. That might help you remember. Let's look at some practice. So we're going to look at practice with an equation first. Number 1 says, given the following graph, what is the equation of the quadratic in vertex form? The axes increase by 1 unit. So we want to find the equation of this. So we need to know A, H, and K, and then we will know the equation. So remember, H is the x coordinate of our vertex, and K is the y coordinate. So let's count to figure out what this point is. 1, 2, 3, 4, 5. So that's a -5 for H. And K is 1, 2. So +2. So we can go ahead and set up our equation to be y equals some number A, and then we have x minus h. So remember, our sign changes. So it's going to be a +5 squared plus 2. Okay, so let's figure out what A is. So there could be a vertical stretch. There's not any x-axis reflection, so meaning there's no negative A. It's going to be some positive number. It could be 1, which would be there's not any extra stretching or shrinking or compressing, okay? So we've got to figure out what in the world has happened here. It looks kind of skinny to me, so it's probably a vertical stretch. Here's what I would do. So I'm just going to use this grid. Let's say these are my x and y axes. My parent function, it starts at 0, 0. And if I square 1, I go to 1. And I square -1 and I go to 1. So here's the pattern. From your vertex of 0, 0, you go right 1, up 1. So let's see what happens here. I don't go right 1, up 1. I go right 1, up 2. So if I've gone from a y value of 1 to 2, so it's, again, instead of right 1, up 1, right 1, up 2, that means I've multiplied that 1 by 2 to get to 2. So that's got to be an a value of 2. So that's going to be a 2 there, and we're done with that equation. Number 2, given the equation, what is the vertex, axis of symmetry, and extrema of the following quadratic? Okay, the vertex is going to be HK, so I'll go ahead and set that up. So that equals opposite of what's being added or subtracted to the x, so instead of a -1, it's a +1. Remember that h is subtracted, so the sign swaps. And then whatever's out in the end, that's 6. That's it. What's the axis of symmetry? Okay, remember that's going to be AOS, axis of symmetry. That's always going to be x equals the x coordinate of the vertex, which we just found, so it's x equals 1. And remember, that means that it's that line, okay? And actually, I don't want to draw it that way because this negative right here tells us that's going to be an x-axis reflection, so it's going to be a maximum. So we know that we've got a max at y equals something. So the top, it's got to be that k value, right? So it's going to be y equals 6. And that's really all there is to that one. Number 3, given the following graph, what's the vertex, axis of symmetry, and extrema of the parabola? The axes increase by 1 unit. Okay, so it's the same question as number 2, but instead of an equation, we're given a graph. So again, all of these properties come from knowing the vertex, so let's find that first. So here's our point of the vertex. That's going to be left 1, 2, 3. So that's going to be -3 for our h. And we go 1, 2, 3, 4 down for our y value, so a -4 for our k. Okay, let's find our axis of symmetry. If you want to write out the whole words, a axis of symmetry, that's fine. I'm just abbreviating. So that's going to be x equals the x coordinate of our vertex. So x equals h, which is -3. And what's our extrema? Well, we can tell it's a minimum. because it looks like a valley. It's an up, up end paper, up, up. So min at y equals k, or the y value of our vertex, so y equals -4. And again, for the axis of symmetry, that's what that axis looks like. All right, that's it for notes and practice of vertex form. See y'all next time.